Hi, in this episode I'm going to discuss organic chemistry. Now, you might be asking what is organic chemistry? It's very broad range. Basically, it's any chemistry that involves mainly the carbon group. This can be carbon bond into itself or not. This can involve carbon bond into hydrogen, nitrogen, oxygen, fluorine, any of the halogens, most of the alkali metals, um, any D block elements, which is organometallic. But literally, it's just any chemistry with carbon. It's a very broad range. So, first things first, when you're doing organic chemistry, the main thing you'll come across is there's a lot of quite complex names that you'll come across. So, IUPAC has developed a special set of rules for naming the compounds. This allows any chemist around the world to communicate about chemicals with any other chemist around the world, in organic chemistry at least. Other inorganic chemistry has its own rules, but there's some rules that are commonly broken to avoid massive long names, because sometimes you get really long chemical names, and you'll have a generic, for example, and naturally it's not that bad a one, but acetyl salicylic acid is often called aspirin, and even acetyl salicylic acid is itself not the full IUPAC name. So, getting on to the basics and nomenclature, because there's a lot to learn about it, but it's very important. So, your basic nomenclature involves your hydrocarbons, and these are named in how many carbons you have. A hydrocarbon is just any compound that solely contains carbon and hydrogen, no other atoms, no heteroatoms. So basically these are named in order of their chain length. So this one here you can see is hexane, because you've got 1, 2, 3, 4, 5, 6 carbons. So 1, 2, 3, 4, 5, 6 hex. And ane just refers to a straight chain. So we've got meth, eth, prop, but, pent, hex, sept, oct, non, and dec. All of these are prefixes for when you have a carbon chain. Now, when we're naming them, we like to pick the longest carbon chain out of any compound. So, can you guess what this one is? I'll just pause for a break. You can work out what the longest chain is. Don't worry about the side groups if there is any. Right, so hope you've got hexane. So you've got 1, 2, 3, 4, 5, 6 carbons is the longest chain. There are other routes through it which are backbones, but they're not the longest. For example, 1, 2, 3, 4, 5 would not be the longest. And also you've got 1, 2, 3, 4, 5 again here. So it could be easy to mistake this for a 5 carbon chain backbone, but it's in fact a 6 carbon. So what this chemical is called is 3,4-methylhexane. So the hexane comes from this, the methyl comes from your meth and the end group, so it's an aisle. And 3,4, when you've got the backbone, you name you number the carbons as they go along. So that'd be carbon 1, 2, 3, 4, 5, 6. Or it could be reversed, 1, 2, 3, 4, 5, 6. So you've got the 3,4 refers to the fact that each methyl is bonded to either group carbon 3 or carbon 4. It's interchangeable because it's a symmetrical molecule. So I'm going to go into some functional group naming and how you add them. So obviously we know this is hexane here, and I've named them 1, 2, 3, 4, 5, 6. So hexane 2-ol as a chemical, well, as a functional group, such as your hydroxyl functional group here, or your alcohol as it's also called, binds to a carbon, it gets given a number. And generally this is suffixed unless there's another chemical that takes precedence, and then you get prefixes as well. So, as you can see, hexane 2-ol, 1, 2, the carbon number 2 is bonded to the functional group. Now this can trick you out initially, because obviously you'd think number 3 is here, but you name it so it's the lowest number possible. So 1, 2, 3. Otherwise you would have 1, 2, 3, 4 hexane 4 row, which wouldn't make sense because it has to be the lowest number possible. So you start numbering from the opposite end if you can get away with it. And here's a good one. We've got 5-hydroxyhexane 2-on. So the on refers to this ketone group here. But you see that is a 2, and the hydroxy, which is the prefix for an alcohol, because the ketone has taken over the suffix ending, so hydroxy has to be moved forwards to the prefix. So what you'll get here is, because this one takes priority, it's being numbered 2, 1, 2. But you can't number this one 2 as well, because that implies they're on the same carbon. So what you do is you count from this end, 1, 2, 3, 4, 5, which gives you a 5-hydroxyhexane 2-on. Now, I'll discuss more about the precedence of order of chemicals later on, because it can get quite complex and there's a fair few rules about it. But just to make sure you're aware of what's going on. I think this will be a good point to finish at, and you can go away, look on the internet, some more functional groups and things like that. I'll be discussing them later on in the series anyway, as chemistry gets more complex and things. And thank you for listening. I appreciate this has been very simple for anyone who knows a lot of chemistry already, but I'm starting from the basics and working it. So thank you for listening.